here, I discuss about the life cycle of a thread and give some couple of demonstration to make you understand how a life cycle of a thread can be implemented. Fine. Let me start with a very simple example. I import sleep from time package or time module. Okay, time module import sleep. After importing, I just render. After importing, I just print one line, that is let's say first line, and one more print statement, just print second line. Okay, so let's run the code and see. So first line and second line got printed. Now I introduce a sleep method here. I just put 5 milliseconds. Clearly or closely watch my output. First line got printed. Now what happens? So my thread got suspended. Okay, this program got suspended for some time, that is 5 milliseconds, and after that second line got displayed. Okay, so this is the way basically sleep method works. Fine, let me create one more example. Now as usual, we just create a thread first. Okay, so from threading, import the thread class, then import the time as well. So that is required when we need to call the sleep method. So create my class, let's say my thread. My thread, this is extended from thread class, and define my constructor or init method that takes one default parameter, that is self, and inside my init method call the thread dot underscore init, that is a thread method of my thread class, and we can pass the thread name as well here. Let's say my thread. Okay, some name you can pass. Okay, it can be anything. So some useful name, some meaningful name, you can pass it. Now it's defined. Let's override. Okay, now let's override the method run. So actually this normally possesses the logic. Okay, right, put your logic here. So this is the place where you need to put your logic to run. Okay, inside the run, what you can do is you can define something. I put a for loop here for I in range of 1 to 5. Okay, and inside I just print, okay, self dot which thread is running, that we can do get it with the help of get name method. Get name is a method which is used to extract the name of the current thread. Okay, so I'm giving the self reference, that's why the current thread name will be printed. Then with that I am doing a string of I, that is what is in I that I am trying to display. Okay, string concatenation will combine everything and finally that would be printed. And then we have to print the value of I. That's great. Yeah, this is what I want to print. Okay, my logic is done. Now let's create my main. So this is the way we can implement underscore name double equal to underscore main. Now let's start creating a thread. Let's say t1 equal to my thread, t2 equal to my thread. Now what happened here, t1 thread created, and second line, if this create T2 thread created. Okay, it's not at run and it is not in the ready state even. Okay, fine. Now it's time to discuss about the life cycle of a thread. Okay, so that you will understand what is happening after creating a thread, how it is crossing different stages as it runs. So it will be very useful for you to understand. Fine. Now, when you look at the life cycle, initially it is in the born state. Okay, so as soon as you create a thread, so the thread is born. Now, or otherwise we can say that the thread is born. Okay, T1 thread is born, T2 thread is born, but it is not ready to run. So how it becomes ready? As soon as you call a method called start. Okay, there is a method called start. Okay, so as soon as you call the start method, automatically your thread is moving from born state to ready state. Okay, once it coming to the ready state, it will be placed in the queue. Okay, queue is the first come first served data structure where all your threads will be lying here, and in a single CPU scenario, assume that there is a single CPU, all your threads are taken and executed in the CPU in a time sliced manner. Okay, every thread would be getting its own time period of getting executed in the CPU. So your threads are taken and getting executed for a particular time slice, and once it is elapsing the time, it will come out and again go to the ready queue back and wait for its turn to get executed again. In between, when it executes in the CPU, it will come across different states, something like sleep, blocked, dead, and wait. Okay, we will discuss all these things one by one. Now we need to start it. Okay, how to start it? There is a way to start it. Okay, T1 dot start. This will start the thread. Now what happens? T1 is in ready state. Then I can start T2 dot start. Now T2 is in ready state. Fine. So T1 is in ready state, T2 in ready state. Automatically what happens? It start entering the queue and it is ready for the CPU, waiting for the CPU to get executed in the CPU. Right. Now let's run the code and save my code as sleep2.py. Oh, I got an error. Fine. Okay, now this is the problem here. So if I'm creating a single thread, it won't cause problem. So this is the reason why it is creating a problem. If I run it, eval, I got it. I have a thread 91, 92. So it's somewhat it is running in a mixed way. The execution won't be in a particular order. It will be in a based on the some time slice. It's purely decided by the operating system. We do not have any control over it. In what fashion my thread is running. Now we are unable to identify the thread name. So what I can do, I'll use the set name method. Set name method and set a name for my thread as T1. The first thread is named as T1 and copy and paste the same command and sorry, copy and paste. Yeah. Okay, copy and paste the same statement and make it as T2 and set name, the thread name is T2. Fine. Now if you run, you can see that T1 is executed for some time and T2 is executed. Now this is run in a serial fashion, one by one, or T1 after T2. This is not the case always. Okay, run it again. Now you see that T1 got executed, T2 got executed, T1 1, T2 1, T1 2, T1 3, T1 4, again T2 2. But that means this loop is iterating from 1 to 4. Okay, so because I have given the ranges 1 to 5, it's iterating 1 to 4. T1 got executed only once, again T2 completed, again after sorry, T1 got executed for some time and T2 started, then T1 continued, T2 waited and then T2 continued. Okay, this is the way it is running. Again, once again I run. Almost I am getting the similar effect. Okay, fine. Now we cannot predict that what is the way it runs. It's purely depends on how it is being used. Is purely depends on the operating system. Now look at the life cycle. Now what happens as soon as you start, it is entering into the queue state. Entering into the queue, from that picked up by the CPU, and it is running. Now let us demonstrate the sleep method. So how a sleep method is used. Fine. Now how to use the sleep method? I can put a sleep method here. I can say that time dot sleep and some 2 milliseconds. Okay, it executed in a fashion like T1, then T2, T2, again T1, again T2, again T1, T2, T1. Okay, this is the way it got executed. Now what happens when I run the sleep method? Its execution of the program is getting delayed. Now you can print here method started, so that you will get to know that which one is the method which is getting executed first. Okay, main method started. After that T1 got created, T2 got created, and T1 is executed for some time, T2 executed for some time, wait. Okay, now what happens? T1 started. Okay, it comes here, executed. T1 got executed for one time, it went to sleep. Again T2 started. Okay, so meanwhile T2 started, T2 got executed one, it went to sleep. Again T1 executed, went to sleep. T2 executed, went to sleep. T1 executed, went to sleep. T2 executed, went to sleep. That's the way it's get executed. Now you can understand that a sleep function that actually delays it, that is suspending the execution of a process. As soon as a process gets suspended, okay, so from the running state it is going to a sleeping state with the help of a sleep method, and from here it actually go to the rear end of the queue. So from the rear end of the queue, it's waiting. So once the sleep time elapsed, it get a backup signal. From here it will move to the rear end of the queue, then again picked by the CPU for execution. That's the way it goes. Now there are other states of the thread. Now what happens from the running? There is a possibility that it will go to the dead state. Now how come it goes to the dead state? Now look at the code. T2 is again reaching the 4. That means it iterated from 1 to 4. No more cycle is required, or no more code is pending to execute. What happens? T2 come to an end. For instance, when you check out with the T1, T1 is already finished its execution because the iteration is 1 to 4. It has printed 4. Fine, there is nothing to execute now. It will also go to dead state. So in that state, as soon as a thread completes its execution, it goes to a dead state. Okay, after that the thread is not exist. Thread doesn't exist in the system. Okay, it is died. Now some reasons the thread is also blocked. So why it is blocked? Because of some IO. So some IO need to happen so that the thread will be in the blocked state. So it wait for an event to happen. Now what is this event? An IO event, for example. So it is in the block state. As soon as this IO get completed, it's get a wake up signal. Now it will become the status become ready. Then it will again move to the rear end of the queue, waiting for the its stand for the CPU. Fine. Now there is one more state left, that is waiting. So in this case, the thread which is running voluntarily relinquishes the CPU and enter into a wait state. Now why it is entering into the wait state is it is waiting for something to happen. Some state become true. As soon as that state become true, this get a notification. Okay, so once it gets a notification, automatically this move to the ready state. Ready state means again it moving to the rear end of the the queue, and from that it is again picked up by the CPU for processing. So this is the overall life cycle of a thread. So it started its execution, so picked up uh, from the queue, and initially as soon as you create a thread get created. Okay, so this is the way your thread is born. After calling the start method, it go to the ready state. That means it is placed in the queue for execution. It is picked up by the CPU, and every thread is having its own time slice for executing in the CPU. The once the time slice is elapsed, again it moved to the ready state. That means move to the end of the queue, and or otherwise it may come across any one of the state. Okay, like dead, waiting, sleeping, blocked. Okay, I believe you understood the life cycle of the thread, and so start a thread, and how the thread is ending, how to use the sleep method, which basically suspend the execution of the thread for some time. Particularly when we give sleep, if you want to have a fine-grained control, you can give the number in floating point as well. Let's say 1.6. Okay, 1.6 milliseconds. Okay, it wait for 1.2 milliseconds. 1.6 milliseconds and start. Okay, this gives a more fine-tuned control over your thread suspension. I hope you enjoyed the discussion. Thank you for watching the video.